Hey guys, this is Devin Williams, and today I will be going over writing chemical equations for Unit 4 to Intro to College Chem. So, you don't really need a calculator or a pencil. Well, you can have the pencil, that's optional if you want to write this stuff down, but you don't really need a calculator until we get to the next video about moles, atoms, and so forth on this list. So, but what you do need is a periodic table, which I already have, and of course a polyatomic ion sheet, depending on the equation you have. You may want to have this on hand. So, without further ado, let's get started on writing chemical equations. So, the first one we have is a combination or synthesis reaction. So, basically, this kind of reaction is where two simple compounds or simple elements come together and become a more complex compound. As you can see, A plus B equals AB. So an example would be magnesium plus oxygen yields to magnesium oxide, becomes this. So two simple compounds come together to become one more complex compound. So now since that has happened, are the charges set to 0? Yes, they are set to 0 because magnesium has a 2 plus charge and oxygen has a 2 negative charge, so they balance each other out, so this is at 0. Now, is it a balance equation here? No, it is not, and if it is not balanced, then we must balance it. So, this is it balance. We must always balance our chemical equations, no matter what, to get the most accurate answer for moles, atoms, and so forth, depending on what you're doing. So this is it balanced. Okay. Next one is a decomposition reaction, which is going to be the opposite of a combination reaction, where a complex compound is broken down into simpler particles. So let's look at an example. Water is broken down into hydrogen and oxygen. And as you can see, hydrogen and oxygen have an H2 or an O2. That's because they are diatomic elements, which means that they can never be alone. So these elements, along with nitrogen, fluorine, chlorine, bromine, and iodine, are always going to have a 2 by itself. So, as we can see, this is the equation. Are the charges set to 0? Yes, it's set to 0. Now, is it a balance equation up here? Nope, but it is balanced down here. So, as you can see, I have already balanced. So, like I said, always balance your chemical equations. 2, 2, 0, or 1 technically, because we don't really need to put the 1, but if you want to put the 1, that's fine. You can put the 1. Doesn't really matter. So, now since we've gotten to decomposition reactions, let's go to single displacement or single replacement chemical equations, which is basically this. A plus BC equals C plus AB. It's where one element switches or replaces another element in a compound. So, as you can see, A has switched with C, now C is by itself, and now A has formed a new compound with B. So, let's look at an example. Aluminum plus hydrogen sulfate yields to aluminum sulfate plus hydrogen. So, as you can see, aluminum has switched places with hydrogen, and now it's become this new compound. So, are the charges set to 0? Yes, it's set to 0. Is this the balance equation? No, as you can see from down here, it's not a balance. This is the balanced form of it. This is not, so now we have to balance it. And this is what it will be balanced. So, there you go. That's how you balance a single displacement equation, single displacement replacement. So, now, since we have done that, let's go to double displacement, which is right here. So double displacement is where the positive ions and the negative ions of two compounds switch places to form different compounds with another ion, or different compound or element. So as you can see, A plus B plus CD. As you can see, this is the original. They have switched places with another element, and now it becomes AD plus BC. This is it broken down in its simplest way. So let's look at an example. Calcium chlorine plus sodium fluorine. These are the originals. switch the places or switch the elements, it becomes calcium fluorine plus sodium chlorine. And this is the new ones. Are the charges set to 0? Yes, they are set to 0. Now, is it a balanced equation up here? No, it's not. So, because the fluorines have different amounts and the chlorines have different amounts, so we have the balanced equation, which I've already done, which is right here. This is this equation balance. So 1, 2, 1, 2. Okay. So if you don't really get balancing, all you really are doing is just looking to see how many of each element is on one side and then see if there's the same amount on the other side. But since we didn't have the same amount on this side for fluorine or chlorine, we have to do it here. So we just leave this alone because we have the calciums the same, and the chlorine is already 2 here, so we could put a 2 right here, and then we get 2 sodiums and 2 chlorines. Now, of course, our sodiums need to be balanced, and then put a 2 here because sodium is with fluorine. And now, it's all balanced. Yay. So, let's look at the final type of chemical equations, or writing one, which is a combustion. Now, this is when a compound containing carbon and hydrogen, or sometimes oxygen, combines with oxygen gas to create or form carbon dioxide plus water. So, this is it broken down in its simplest form. Carbon X amount plus oil times H amount, some chemical equation, or sometimes oxygen amount, plus this, O2, creates these. So, now that as simple as that has been explained, let's go to an example. So, we have propane, which is C3H8 plus oxygen gas yields to CO2 plus H2O. The charges have all been set to 0, but now is this a balanced equation? No, it's not, because the carbons have different amounts. Same thing with hydrogens and oxygens. So, as you can see, I have already balanced it. This is the equation balance for this combustion equation. So, there you have it. This is writing chemical equations for Unit 4. I hope that you enjoyed it and maybe have learned something from it. Okay.